Hi grade 7s, welcome to another online math video. This video goes over the answers to the unit review, which can be found on pages 44 to 46. I assigned this classwork to help you prepare for our end of unit quiz, which is tomorrow. If you're having troubles, please study this video, rewind to the questions that you're having problems with. Please use it as a tool to help you. Okay, question 1 asked us to use the divisibility rules to find all the factors of 90. So with questions that involve factors, as always, the first factor you'll have is 1. It goes in evenly to any number. 2 obviously fits because 90 is an even number. 3 fits as well. If you add the sum of the digits together, 9 plus 0 equals 9, which is a multiple of 3. 4 won't work because 90 is not divisible by 4. 5 will, because it ends in 0. 6 also fits in 90, because 2 and 3 fit into 90, so therefore 6 will as well. Skip count up to some known facts. You'll know that 7 will not work, 8 will not work. 9, of course, works, because 9 times 10 equals 90. Now, we have made the middle, we've reached the middle here because 9 times 10 equals 90, so therefore we can continue our factor fan. All we need to figure out is 90 divided by 6, and that will be our next factor. So here, 15 times 6 is 90. Next we find out 90 divided by 5, and that will give us our next factor, which is 18. How many 3's can fit into 90? 30 can. How many 2's fit into 90? 90 divided by 2 is 45, and we close out our factor list with 90. So here there are 12 different factors. On the quiz tomorrow I will give you a different number. Each correct factor that you can answer is worth half a mark. Question number 2. Is 23,640 divisible by the following numbers? By 2. You have to say yes or no and then provide an answer as to why. It is divisible by 2, yes, because it is an even number. By 3, yes, because the sum of the digits is 15, which is divisible by 3. 4, yes, because 40 is divisible by 4. Again, the last 2 digits are the ones to look for with the 4's. 5, yes, because it ends in 0. 6, yes, because the number is divisible by 2 and by 3. 8, yes, because 640 is divisible by 8. When you look for the 8's, you look for the last 3 digits in the number. By 9, no, because the sum of the digits is 15, which is not divisible by 9. By 10, yes, because it ends in 0. The textbook also asks you, is the number divisible by 0? No, because no number is divisible by 0. Question number 3 was a tough one. I am a 3-digit number. I am divisible by 4 and by 9. My 1's digit is 2. I am less than 500. Which number am I? Find as many as you can. So for this, as a strategy, we start from 100. And we go up. The first one you could have that ends in 2 is 102. That is not divisible by 4 or by 9. 112 is divisible by 4, but it's not divisible by 9. You continue going up until you reach a number that is divisible by 4 and by 9. Here, 32 is divisible by 4, but if you add all the digits up together, it equals 6, which is not a multiple of 9. Therefore, it won't work. These numbers won't work either. So there's really no easier way to do this. If you continue going up, you'll find out that 252 is the first one. 52 is divisible by 4, and 252 is divisible by 9, because if you add the digits up, 2 plus 5 plus 2 equals 9, which is obviously a multiple of 9. The next one that you could find, 432. Again, 32 is divisible by 4, and 4 plus 3 plus 2 equals 9, which is a divisible multiple of 9, therefore it's divisible by 9. Question 4, our good friend the Venn diagram. On the left were numbers that are divisible by 6, on the right numbers that were by 9. So with the long list of numbers, I believe there were 8 numbers. First number, 330, divisible by 6, but not by 9. 858, again divisible by 6, and you check these two numbers, how we find out both of those numbers are divisible by 2 and by 3. Next, 639 is divisible by 9. It's not divisible by 6, and how I can tell immediately is because it ends in an odd number. If you were to skip count up by 6, you would always land on an even number. Therefore, a number that ends in an odd cannot be divisible by 6, which rules out 2,295 as well. Both of these numbers are divisible by 9 because if you add them up, the sum of the digits equals a multiple of 9. They both equal 18 in this case. Numbers that are divisible by both, if you add all of these digits up, 5 plus 5 is 10, plus 9 is 19, plus 8 is 27. 27 is a multiple of 9. This number is also divisible by 2 and by 3, so it has to be divisible by 6 as well. The same can be said for 12,006. The last two numbers are not divisible by either 6 or 9. Question 5. Write an algebraic expression for each statement. Then the next part was to evaluate each expression by replacing the variable with 8. So the first one asked us, 5 less than a number. Our algebraic expression, n minus 5, I'm replacing that n with the 8 in this case. 8 minus 5 equals 3. Question B. A number increased by 10. Algebraic expression could be n plus 10. I replace the n with 8. I'm left with 8 plus 10 equals 18. Triple a number. Our algebraic expression would be 3n. I replace n with 8. 3 times 8 equals 24. 6 more than 3 times a number. Here, 3n plus 6 is our algebraic expression. Replace n with 8. 3 times 8 plus 6 equals 30. Question 6 we didn't have to do. Question 7 asked us to copy and complete the table. How is output related to the input? So our first one, if this is n and the output is n plus 13, all we do is replace each one of these numbers in the place of n. I'm left with the following numbers. If I'm asked how is output related to input, I would say that output is 13 times, is 13 more than the input. Now I just take these numbers here in B and I place them in the place of n, and I'm left with the following numbers. When asked to describe how they are related, I would say that the output is 1 more than 5 times the input. Here, replacing each c, this should be n actually, n, in the place of this n here, I'm left with the following numbers. How is the output related to the input? It is always 3 less than 6 times each input. Question 8. Write a relation for each input-output table. So my question is, how am I getting from each input number to the output number? It clearly shows that each output number is 11 more than the input, so therefore the relation or expression would be n plus 11. Question B isn't quite so straightforward. You'll see that there's no number that I'm adding up each time to get from input to output. I'm also not multiplying, so that implies a two-step operation. In this case, I notice with the output, each time I go down an output, it's increasing by 5. So therefore, I know the input is going to be multiplied by 5. If I multiply 1 times 5, I get 5, which happens to be 3 more than 2. If I multiply 2 times 5, I get 10, which happens to be 3 more than 7. So therefore, I can figure out my expression is 5n minus 3. Question 9, difficult for me to represent here on my PowerPoint. So just know that A was matched up with 4, B was matched up with 1, and C was matched up with Roman numeral 5. Question 10. I apologize for the small print. For each relation below, describe a real-life situation, make a table of values, graph the relation, describe the graph, and lastly, write 2 questions you could use you could ask using the graph. So our first relation was 4 plus 2m. I needed to describe a real-life situation. In this case, I picked on my good friend Mr. Hughes. Mr. Hughes has 4 action figures. He collects 2 more figures for every month. So he's going to start with 4. Okay? This m would represent the month. So therefore, when I'm making the table for my next requirement, these represent the months. And the output, all I simply do is I replace each one of these inputs with m, and I'm left with the following outputs. So therefore, if after 5 months, Mr. Hughes would have 14 Star Wars action figures. Next, I need to graph the results. These are my input. Again, input is always on the x horizontal axis. I place my outputs on the y vertical axis. Note that I don't have 14 squares here, or 14 vertical lines. So therefore, I've chosen to go up by 2. And then it's just a case of lining up where 1 would be with 6, 2 would be with 8, and it would look like that. 2 more questions that I could ask using the graph. Oh, I need to describe the graph first, sorry. Each time the input goes up by 1, the output goes up by 2. My questions: after 6 months, how many action figures would Mr. Hughes have? So I would go to where 6 would be. I would follow that. It would be 16 action figures. And again, I would just follow the pattern in my table as well. After 7 months, it would be 18 action figures. So, one more, only this time with a different expression. 15 minus 2d. My real-life situation could be I started with $15. I bought a $2 donut each day at lunch. If I were to make my table, again, replacing the input in the place of d for the expression, and these are what the output numbers I would get. I would graph the relation. Again, I don't have 13 vertical lines, so in this case, I've gone up by 2's again, which is just fine. You'll see that none of the numbers here are even numbers, but I can still go up by 2. I would just plot my points here, and notice that 13 would fall right in between 12 and 14. When describing the graph, when the input goes up by 1, the output goes down by 2. 2 questions I could ask would be, after 6 days of buying donuts, how much money would I have left? So I would figure out where the 6th day would be, and I would have $3 left. If I continued my graph, the 7th day here, I would have $1 left. Question 11. Gerald is paid $6 to supervise a group of children at a day camp. He is paid an additional $2 per child. We need to write a relation, or an expression as we call it. So in this case, 2c plus 6 is the relation. Copy and complete the table. So these numbers were given for you, okay, not the traditional 1, 2, 3, 4, 5, etc. So in this case, all I do is pop this number in the place of C to get my output, or amount paid. Graph the results next. So again, my input, which is on the left-hand side, would go on the x horizontal. And now my output would go on the vertical y-axis. And again, I don't have 36 lines, so in this case, I've gone up by 5. Just a case of lining them up here. 0 would equal 6. 5 would equal 16, etc. That represents a linear relation. If we had to describe the graph, you could say that when the number of children increases by 5, the amount paid increases by 10. How much does he get paid to supervise 25 children. So if you were to continue this, or continue the table as well, you would find that he would get $56. How many children did he supervise to earn $46? Correct answer would be 20 children. Question 12. Select a real-life situation that could be represented by this graph. This was a tough question. A clue could be to figure out the expression first. So if I have my table here, if I would figure out here 0, 4, 8, and where they would line up in the output, so 0 would line up with 24. 4 would line up with 32. And I could figure that out and continue the pattern. And from here, I have to figure out the expression. How does each input number get to the output number? And this is very tricky because you'll see that normally we've got our 1, 2, 3, 4, 5, and if it's continually skip counting up by 8, you would suggest that maybe it's 8 times a number. But in this case, what you need to visualize is that between 0 and 4 are the numbers 1, 2, and 3. So once you figure that out, you will notice that each time the input number increases by 1, the output number would increase by 2, and therefore it would indicate that it's multiplied by 2. So in this case, the expression is 2n plus 24. To figure out a real-life situation, I chose my default as Mayfair. It costs $24 to get into Mayfair, plus $2 for every ride. Question 13. Write an equation for each sentence. A pizza with 15 slices is shared equally among n students. Each student gets 3 slices. So in this case, the total amount of pizza is 15. There are 3 slices per student, so therefore 3n equals 15. B. 4 less than 3 times the number of red counters is 20. Again, that word is often represents equals. So in this case, 3n minus 4 equals 20. And for these questions, we don't need to solve. All we're doing is writing the equation. 14. The drum ring of the hand drum is a regular octagon. It has a perimeter of 48 centimeters. Write an equation you could write to find the side length of the drum ring. Write an equation does not mean we need to solve it. So what we need to figure out here, the unknown number is 8. We should know that an octagon has got 8 sides. So therefore, if the perimeter is 48, we are left with 8n equals 48. Question 15. We had 4 different questions for each A and for B. A. 36 people volunteered to canvass door-to-door for the Heart and Stroke Foundation. They were divided into 3 groups. How many groups were there? So if we have to write an equation, which is represented by Roman numeral I here, Roman numeral 1, our equation would be 3n equals 36. To solve the equation, we just have to figure out 3 times what number equals 36. The answer is 12. If we had to draw pictures to show the steps, here, I've got 3 variable tiles on the left-hand side of the equal sign. I've got 36 unit tiles. I've organized them into 3 equal groups, and therefore, each group is representative of the answer. X equals 12. To verify the solution, I put 12 in the place of n, and I solve to make sure it is correct, which it is. Question B. A garden has 7 more daffodils than tulips. There are 18 daffodils. How many tulips are there? So in this case, 7 more is key. Okay, so that's going to indicate it's an addition problem. So if we let t equal tulips, we have t plus 7 equals 18. If we had to solve it, we could figure out the answer is 11. If we drew pictures to show the steps, here on the left-hand side of the equal sign, we have t, or the variable, plus 7 equals 11. To get that t all by itself, we need to take away the 7 tiles that are here. We take away the 7 tiles on the right-hand side of the equal sign to balance the equation. If we verify the solution, 11 plus 7 does equal 18. Question C. A sleeve of juice contains 3 juice boxes. Marty buys 24 juice boxes. How many sleeves does he buy? So in this case there are 24 total, 3 groups. So 3s, s representing sleeves, equals 24. Solving the answer is 8. Here we have pictures, 3 variable tiles, 24 unit tiles on the right hand side. Each variable tile represents 8 unit tiles. Verifying the solution, 3 times 8 does equal 24. Last one in question 15. Jan collects foreign stamps. Her friend gives her 8 stamps. Jan then has 21 stamps. How many stamps did she start with? So she has 21 total stamps. That would indicate it would be after the equal sign. Her friend gave her 8 stamps, so therefore that implies addition. S for stamps plus 8 equals 21. If we solve it, the answer is 13. If we draw it with pictures, we have S plus 8 on the left-hand side, 13 on the right-hand side, and we take away 8 from both sides to leave in this case, S equals 13. Verify the solution, and it is correct. Question 16, a number is multiplied by 4, then 5 is added, the result is 21. What is the number? We have to write an equation. 4n plus 5 equals 21. Solve the equation to find, that should say, number. N equals 4. If we verify the solution, we put 4 in the place of n. 4 times 4 plus 5 equals 21. Using our order of operations, we do the multiplication first. 16 plus 5 does in fact equal 21. Good luck on the quiz, everyone. Study this video and you'll do very well.